Okay, I'll show you a little bit of my dilemma here. I have these four boards wired in parallel for where the blue is positive, the black is a common ground. And right now I have these connected to nothing, which doesn't really matter because I am feeding power in from a switch mode power supply, and it's developing 12 volts and it's putting it onto the board here. But that's okay because all these boards are connected in parallel, so it's actually feeding all four boards, and it's feeding all the meters as well. So all of this meter and everything lit up is because of this power supply. I have a separate power supply that I am feeding for the load. It's a 12.5 volt and it's got 5 amp max, and right now it's feeding 12 volts through this 8 ohm resistor, through the current reading circuit on this meter, and back to the power supply. So right now I'm drawing 4.95 amps, if you can see that. 1.495 amps. So just about amp and a half there. But I can't get the voltmeter to work. When I connect the voltmeter up to the positive for the power supply, I get nothing. Nothing happening. Okay? So what I did is I took the power supply off and reversed the polarity. So now I'm back feeding the polarity reverse through this shunt, and you can see it says 0. But if I connect up the sense wire, yes, here it is. Now it starts reading voltage. I got a 12.3 volts, 12.07. So part of the problem is that the voltage sense and the current shunt sense are connected together inside this meter, and I can't separate the two. Obviously I can't feed the power into the meter backwards because I'm not getting any reading on the amp meter, even though the voltmeter works. Let's see, there it is again. But I need to figure out how I'm going to overcome this business with the amp meter needing current in one direction only. I have to think about this because I don't know if it's possible. These meters might be no good for my project, and I might have to look at a completely different meter, which is unfortunate because I already butchered the cabinet to make these fit. But let me put my thinking cap on to see what I can do here, and maybe I can sort this mess out. I thought by providing a separate power supply I should be able to isolate the load from the power source for this, and it seems to be working. It's just that I can't get the meter to work properly, and I'm wondering if I put the meter in below the let's see here. I'll show you. Right now the way it is I'm trying to put the meter in right here. I'm trying to put the meter in here so that it measures current flow through this. But what I might have to do is move the meter to the ground and put it as part of the ground network. I'd have to modify these boards, but I could put the meter in below here where the grounds could be tied, and I don't have to worry about shunting any voltages down, and it might just work. Let me think about that. Alright, so what I decided to do is divide and conquer. What I did is I just going to work with one board, one meter, and we'll try and get this arrangement working. and then once it starts working, or if I can get it working, I can put the same to the other three. So this is essentially a completely wired up circuit. I have a heatsink, and I got 4 MOSFETs on there. These are IRF P450Zs. They're switch mode from out of switch mode power supplies. These are heavy duty, tough. They're rated 14 amps each at 500 volts, and these are very capable MOSFETs for using for this. And I just cut a couple holes and bolted them down to a computer heatsink. So that's my load wired in. I got the I'll show you what I did. I'll show you what I'm doing here, because I don't know, I just want to make sure this makes sense to you. What I was trying to do is put my ammeter in line with the input. So this will be plus, this is minus. This is what's coming in for my load. This is my test power supply. Okay, that's connected there. And I have an ammeter here, or I did have an ammeter here, and it feeds the drains of these 4 transistors, and depending on how much these transistors are turned on by, or MOSFETs are turned on by this op amp, depends how much current is sunk. Each one is capable of, you know, sinking current, and this goes directly to ground. So what I had is I had wired this in, and I put the ammeter here, and I was paying attention to plus and minus, and also from here, let's just draw this voltmeter, and I was taking the yellow. And tying it off, and I was using this to measure voltage. Now I could get the voltmeter to work, but I couldn't get the ammeter to work because what it was doing is it was dead shorting. Something to do with the power supplied to this and the power supplied to this. This doesn't exist here. There's no diodes. This is my positive input, 12 volts, and then ground. I was getting a short somewhere between this, and it was killing the system, and it wasn't working at all. So I had an idea. Take the ammeter from here, and instead of having it on the supply side of the load, I was going to move it to the drain side of the load. I know this is drain, this is source, but so what I did is I cut ties. I cut off the ground for all of these resistors, these 4 resistors, these 0.22 ohm resistors. I cut the tie it had to ground, and then I connected them together. Connected all these 4 together, and then I had a wire, and then I put the ammeter here. And then I grounded it. So the ammeter is on the bottom of the circuit, and it's the last thing before ground. So that's the ammeter. There's no ammeter here anymore. This is straight wire. And this is what I did here with this. So I just want to try this out. I have it all wired up. And I have, let's see here, this will be my input for the load, my input voltage from power supply. This is my meter. This is my heatsink and electronic load. This is my 10-turn pot for adjusting. So let's see if this works at all. So I got power supply hooked up back here, and we're going to supply it with 12 volts. So I'll turn that on. Isolation transformer turns on. The meter comes alive like it should. And next we need to turn on a power supply. and connect it positive to positive, negative to negative. And my power supply is set for 2.9 volts, and it says it's giving off 590 milliamps. So here we go. This is working now. It's got 2.6 volts and 600 milliamps for a total of 1.5 watts. So let's try turning up the current. Actually, you know what? I got my pot wired backwards here. That's minimum. Yeah, I'll have to fix that. The wiring on this, it's backwards. Let's turn up some voltage. I'll give it 15 volts. And we got maximum current. Okay. Turn this up, see how it does. So we're starting to conduct these transistors. 100 milliamps. Let's take it up to an amp. My power supply is starting to, it has an automatic fan in it, so it just kind of, fan kicks in when it's loaded. So we're at an amp there, drawing 15 watts. These resistors are still cool. And this is still cool. I expect this to take a lot of heat before it warms up. Let's crank it right up. I'm kind of pleased this is working because it means I don't have to abandon the project. Okay, right there we're consuming. When I touch it, it goes crazy. Consuming 51 watts right now, 3.6 amps. These are still cool. You got to remember this 3.6 amps is shared by these 4 transistors, so they're not even seeing an amp each. I really kind of overbuilt this thing. Turn it up. My power supply is good for 5 amps. And we are getting, I got it maxed out and I'm only getting 4.7. I hope that's not a limitation. Yeah, now it's starting to get warm. Yeah, it's starting to get a little warm now. Everything's running good. So I'm pleased with this. This is a success result. Okay, now what I can do is I can take this, I'll clean up all this wiring. I'm not going to use this heatsink. I'll use a different one. I'll probably stick with 4 transistors per channel. And then I'll, it's starting to get fairly warm. 65 watts going in there. It's heating up pretty good. Give it some more voltage. Current stays the same. I'm at 31 volts now. 31 volts in my power supply, 29 point something here. I'm losing, you know, resistance in the leads and stuff. I'm not going to use these flimsy wires. I'll get some better wiring. Now we got 140 watts into this, and it is getting nice and hot. So I'm just going to turn this down. So it's not getting so hot. Quite a bit of heat here. Okay, so this is good. This is good. Now I can transfer this into the cabinet, and we can start wiring everything together. I'm glad this worked, from moving the ammeter from this spot to this spot. And like I said, it's working good now. It's measuring how many watts. Perfect. That's exactly what I wanted. So a problem with these meters is the bezel is very dark. I don't know if I have a flashlight here. Maybe the white flashlight, but you can see it's really dark. And it's not really a color that you want over a red LED. Usually you want a red filter, not a gray one. But I was looking at this, and it's like actually two layers. One layer's stuck to another layer. You got the back, which is plastic, and it's molded, and then they have a sticker on top with the volt, amps, watts, and the holes punched in it. So what I did is I just take a knife, and you can see where the window is. I don't know if you can see that. There's the window is, you know, but you can see from the other side. Just take a knife and score it deep and straight with the window. Do this on both sides of the window. Hopefully this will turn out. And I just crack it. Crack this one, and then peel this middle part off. Now you get rid of this. This is all this does is it just kills the light, and then you have this part which can fit into the and then you don't get such heavy-duty attenuation of the light. So that's what I'm going with. Okay, I just want to show you how it's taking shape here. I'm starting to get things assembled, and that's what it's going to look like from the front once all the everything's assembled. I have power switch here. I put a blue LED in it, and it's going to go right there. And then I have, where is it now? I have a fuse. This fuse holder here is going to be a front panel fuse for the power supply. Just because on the back I don't want anything. All I got is an IEC connector on the back for power, and I got it into a small mains filter. And then this printed circuit board, I have to move back about probably let's see, because it's hitting the power supply switch, right? So I want to make sure. I'll probably have to move it back about 3/4 of an inch. Yeah, doesn't really have to go back that far. I can move it back about an inch and so. Just so it clears this switch, that's all I'm concerned about. I don't want anything touching the switch. Yeah, so this is what it looks like. And it's starting to come together. I'm not really doing any wiring. I'm just kind of assembling everything and getting things to fit properly. And I think it's going to turn out good. So that's all I got for this one. Power supply. It had a 2.5 amp fuse on the input, and I think I'm gonna maybe leave that fuse there and just go with a 2 amp fuse at the front. I can't see this thing drawing 2.5 amps. It's ridiculous. But yeah, I'll just leave that fuse in place, and then I'll put an additional fuse. I was thinking of taking it out and bridging it, but I'll just leave it. What else? That's about it. Everything else is falling together nicely. So next time I think I'll be looking at heat sinking and some cooling. So stay tuned. Alright, thanks for watching.